Hey guys, welcome to part 4, day 1. And today we'll just finish up whatever we learned yesterday. Today will be slightly shorter, but it'll be fun nonetheless. So, what we're going to be doing is today we're going to be combining whatever we learned in the past time, and we will also do a GPU check, right? So, only if the device is queued up, then it is, running a GPU, otherwise, it's running a CPU. You can change it by going up over here, and you can actually change the device type that you have. So right now you can see over here, connect to hosted runtime, change runtime type. So if you change this, you can see it's CPU. If I change it to GPU, I will get CUDA. I will not do that right now, but if you were to do it, you will get CUDA. So going forward with what we did yesterday, we will first print what device we have, right? So we can do if torch.CUDA is available. So we can just do torch.device and we should be able to figure it out, right? And just give me 1 sec, right? Where is that? Ta-ta. Okay. Yeah. So wherever the tensor can be actually stored in different places. So I can write over here, tensor is again torch.tensor of 1, 2, 3, 4, 5, something like this. And now I can write over here tensor dot dev, you get device, right? And what we can do is we can just do print. Okay. And whoops, and we can also write. Oops, what torch is not defined? Did I write it correctly? So you gotta, because I reran it, I think all of the RAM, everything is taken out. That's why. So right now it's CPU. So if it's a GPU, so let's say I want to transfer this thing. So I can say it here. I can just do tensor dot move. Okay, so not move. I think it is 2. Yeah, 2. And under this 2, we can write CUDA, right? Tensor.device, or rather we can tensor. Device. I don't think this will work because we don't have the GPU instance currently. So there are no NVIDIA drivers, but if it were there, then this is what we would do. I'm just putting it out there. Okay. And now that we have done that, we will start with a very basic example. So let's say you have a batch size, you have feature dimensions over here, and you have data. This is torch.randn, batch size, comma, feature dimension. So torch.randn is a way of creating random numbers in a torch library, right? I think we did that. Then labels is equal to, again, he's making a single tensor. Then for IDX, comma, features, comma, label, that's in the tuple, right? In enumerate of zip data, comma, labels. Okay. So what he's doing is he's zipping data and labels together. He's combining them because he's given a batch size as 4. So he's giving you an array with that number, and that's how he's iterating over it. In this case, the practice exercise for today is for heights, you got weights, you got names. So for names in the combination of all of this, yeah, we can create random data is equal to torch.random 5, 10, shape random data shape. Okay. I think this is a very good example of today's this thing. So just from memory, if you would like, height is equal to torch.tensor of, oops, let's just put a bunch of tensors, right? And we'll put it as maybe 170 centimeters, 5, 176, 190, and then you got weight is equal to torch.tensor. I mean, this is just a random tensor anyhow, right? Like 35, okay, 35 is a bit too less for a, so I'll put it as 65, 75, 80, 100 or something like that. And then I could say for, yeah, I think this is pretty height val, comma weight val in zip, print height. And wait, you could do that. Wait. We could also put names is equal to torch dot. So no, I don't think we can do Torch.tensor for names. We're just gonna make it a normal array. Okay. So we will make it, I don't know, Alice, Bob, and then oops, what did I miss? Okay, that's what I missed. Yeah, P Dan. Okay, let's go. And now what we can do is zip name. Okay. And what does that mean? Cool. I mean, you can do whatever, and you can make different dimensions if you like. Torch dot rand n 3,2. Then we can just go over here. Print. So this is just creating a random torch tensor. That means 3 rows, 2 columns. And I can probably multiply this by 80. So you get all the values expanded by 80, so on and so forth. So this is today's preview. We can actually start a part of day 2 as well, today itself. And what we can do is we can again import torch, create a tensor. We can look at shapes. So 2 rows, 3 columns, 2 comma 3. Or I think we have done that. Then element-wise operations. I think we have done a plus b, a minus b. If they're the same size, you can easily do it. If it's like a one-dimensional tensor, it's just simple matrix. They need to be same dimension. But if they're not the same dimension, then something different happens. And I would like to show you that. And if it even works, right? So actually, let's do element-wise operations also for torch. Okay. So we can do A is Torch.tensor. Okay. And over here we have an array which itself is a combination of 2 arrays. So there we go. Okay. So this is what do you call 2 cross 3. Okay. So 12, 34, 56. Then 18, 45, 12. Okay. So this is a 2-dimensional array. Okay. So we call this as A tensor. Okay. Now this A tensor, what we're going to do, we're going to modify with B. But B is a special tensor. It is basically Torch.tensor, but it's only 1 cross 3. Okay. So it'll be 1, 2, 3. Okay. That's all B is. B tensor. So now what we can do is we can print A tensor, print B tensor, print A tensor, B tensor. Okay. So now you wouldn't expect this to actually add, but it is still adding because it does some operation, right? It's giving me 13, 36, 59, 19, 47, 15. That means he has doubled this. He's duplicated the row and then he has added it. So 12 plus 3 is 15, 45 plus 2 is 47. So he's duplicated this row twice and he has added it, right? That's what he has done. But what if we were to do this? Now what happens? Okay. Now it won't. At least the size of a tensor 3 must match the size of tensor B2 at least. Okay. So the size of tensor 3 must match the size of tensor B2 at non-singleton dimension. Okay. So I will give you an example. let's take C tensor, which is basically Torch.tensor of this of 1, comma 2. Okay. So now if I were to do this, oops, test now, my bad. Okay. So if you were to do this, you can see when it is adding it, it is 13, 35, 57. 13, 35, and 57. That means he has added 1 completely to the top and he's added 2 completely to the bottom because he's added 2, 2, 2, right? Because it's the same, at least one dimension is matching, and then he just duplicates that value across, right? Now you this, take this, put it over here, and instead you put here, I put it here 2 comma 4 or 1 comma 4. Okay. So this is D tensor now. Oops. So now again, the size of tensor 3 must match the size of tensor B2 at a non-singleton. So at least one of the dimensions must match. This is for addition, subtraction, multiplication, and so on and so forth, right? So now, whoops, oops. So what is a shape? Okay, so we can again go by the rules. Okay, print shape of a tensor is, okay. So now, oops, what? Wait, what? It can't show the shape? 1 second. Huh. Wait, did I forget how to do the shape myself? Oh yeah, you can do Torch.shape. Or is it size? 1 second. I apologize. Oh no. Oops. The problem is I don't read the errors. Yeah. Now I mean it is correct. Obviously. Oops. So what did I just press? It insert shape. Yeah, it's coming in. So the shape of a tensor is this. Wait, I'm going to first come in. I think there was a small bug there. To get back, shape of tensor, this is a tensor dot shape. So the tensor shape is 2 comma 3, right? Now we can multiply if it's 3, 3 comma 1. So I will show you. I will actually do an e tensor. Okay. Torch.tensor of 1, 2, 3. Okay. So we should be able to multiply a tensor into b tensor. So you do this. Non-singleton dimension 0. So what it actually means. So this won't actually work. If I want this to work, I can't do it like this. I have to multiply, right? I have to use a different operation, which is torch.mul, right? So I can show you that. Over here, so this is what will work. This should give me the right Give me 1 second. e.tensor.shape. 1 second. Oh, okay. So if you see, this will still throw an error, right? But the right way, as I told you yesterday, is to do matrix multiply. So if you're doing matrix multiply and then the shapes match, that is 2, 3, 3, 1, the M and N and N cross MN and NP rule. So then these two ends match and it becomes N cross P, then it will work. So if I do torch.matmul, it'll actually give me the output, right? But if you want to do regular multiplication, then at least both the dimensions must match. That's a scalar, 1:1, right? So this is another example which I've written. Torch.1 3, 2, torch.b random AA star BB, right? So you can do this, and this will not work because the dimensions are different. But the moment I do 1, 2, it will broadcast it. Okay. If I don't do broadcasting, right? So if it's 1, 1, it'll broadcast, it'll just copy it to the other side so that it can match it. But if this becomes 2, 2, it will still work, right? It would still work with random. So if it will be 1, 2, it would just broadcast that value across. Okay. So this is just the basic matrix multiplication. Sorry, even I got confused a bit. I used torch multiplication and a bit of its documentation. But today's this video, hope you liked it. This is just the beginning of PyTorch. So we'll get more comfortable with multiplying tensors, adding tensors, and doing tensor operations from tomorrow. Thank you.